Right, now we're going to have a look at the nucleophilic substitution reaction with cyanide as the nucleophile. The reagent that we'd put down would be potassium cyanide or maybe sodium cyanide. The conditions are a little bit unusual, so we'd say aqueous ethanol and warm as well. For our general equation, we'd say that our X, so X being the halogen, was reacting with KCN, giving us RCN, which is the nitrile itself, as well as a potassium halide. As you can see here, one of the major benefits is that this reaction extends the carbon chain by 1, which is a really useful reaction in organic chemistry. Taking the first example, we use bromomethane, reacting it with potassium cyanide, and this gives us our nitrile compound here, in addition to potassium bromide. Let's have a little look at the nitrile that we've made and look at where the name comes from. So here's the organic product from that reaction, CH3CN. You can see that I've drawn out the displayed formula for it. We can see that there's a triple bond between the carbon and the nitrogen. So this is the nitrile group, which is the functional group. This particular nitrile just has 2 carbons in it, so it's the simplest possible nitrile that we can have, and having 2 carbons, that makes this one ethane nitrile. Now have a go at doing this one. So I've drawn iodoethane, again reacting with potassium cyanide. Just pause the video and see if you can work out what the organic product is. So well done if you got that. CH3, CH2, CN, as well as potassium iodide. And again, just pause the video and see if you can work out what the name of the organic product is. This one's slightly longer, has 3 carbons in the chain, including the nitrile. So this one is propane nitrile. Well done if you got that. 3 further equations for you to have a go at. So I've put down the reactants for you. So spend a few minutes, see if you can work out what the products are, and in each case see if you can name the organic product. They'll all be nitriles. So there are the products for the first one. See if you can name the organic product. So 4 carbons including the nitrile, so that's butane nitrile. For the next one, there's the organic product. So let's have a look at the longest carbon chain including the nitrile. So there's 4 including the nitrile. So we'll call that carbon number 1, which makes that carbon number 2. So this one is 2-methyl butane nitrile. And here's the final one. This time again, naming the organic compound. Our nitrile has 3 carbons, which means that we've got 2 methyl groups, and on the second carbon, so some of you might call this 2,2-dimethyl propane nitrile. Actually, you don't need the 2,2, so I would just refer to this as dimethyl propane nitrile. Moving on to the mechanism then. The nucleophile is a cyanide ion, which we'd see as Cn-. So just have a little closer look at cyanide ion now. If you're asked to draw a dot cross diagram for a cyanide ion, this might cause a few problems. what we realise is that between the carbon and the nitrogen there's a triple bond, and there's a lone pair on the nitrogen, and with the negative charge, let's pop that there, we can see that there's a lone pair on the carbon as well. That means that this can act as a nucleophile from both the carbon and the nitrogen. So who does the attacking? Well, surprisingly maybe, it's the carbon that does the attacking, partly because the nitrogen is a little bit more electronegative than the carbon. So the nitrogen has a better hold on the electrons, which means that the carbon's lone pair is more available than the nitrogen. So the cyanide ion will attack through the carbon. So in our first example, first tip is never include the potassium in your mechanism. So the potassium ions are not going to do anything. So the only thing that we want to see is the cyanide ion showing the lone pair on the carbon. Remember to get the negative charge in. Again, just like with the hydroxide, we're attacking the carbon and we're kicking the chlorine out. If you want to show the partial charges, that's okay, as long as we get them the right way around. The carbon is electropositive, the chlorine is delta minus. Have a see if you can work out what that's going to give us. So well done if you got that. Looks a little bit strange sometimes, the way that we'd show that almost looks incomplete, but remember that there's a triple bond between the carbon and the nitrogen. See if you can work out what the organic product is called. Well done if you got ethane nitrile, and again see if you can remember what the name of the mechanism is. So that's nucleophilic substitution. Let's have a go at another one. Bromoethane this time. And in comes the cyanide ion. We'll just pop it there again. Attack the carbon, bromine gets kicked out. Our products this time so there's our organic product along with the bromide ion. See if you can work out what the organic product is going to be called. So it has 3 carbons including the nitrile group. Well done if you got propane nitrile. Final example, 2-iodopropane with our cyanide. Just put the cyanide down there this time. Very repetitive, but in a good way. Always show the bond between the carbon and the carbon, not the nitrogen, so you can see there my bond between the nitrile and the carbon is not going to the nitrogen, which would be a mistake. Naming this organic product. Again, longest carbon chain, including the nitrile, is 3, so this is propane nitrile, and the methyl group is on the second carbon, although it couldn't actually be anywhere else, so this is simply methyl propane nitrile.